Learning target number 1, we were talking about outliers. Okay, so we talked about that 1.5 times IQR, where the low outlier was less than Q1 minus 1.5 times IQR. Zoom in on B 105. Yep. All right. The high outlier or the upper outlier, okay, is greater than Q3 plus 1.5 times IQR. We didn't talk about this a whole lot yesterday, but we're going to see this a little bit more. There's a standard deviation method as well. Okay, so the low outlier is less than the mean minus 2 of the standard deviations. We're going to talk about this in a little bit. The high outlier is greater than the mean plus 2 standard deviations. There is 3 learning targets, so give yourself enough space. Okay. Learning target number 2, we talked about the 5-number summary. It's just a fancy way of saying the box and whisker plot. So we talked about the min, quartile 1, the median, Q3, and the max. So min, Q1, median, Q3, and max. And then our third learning target, which I'm going to put down here. Okay, we talked about comparing distributions. Okay, with comparing distributions, we talked about the shape, the outliers, the center, and the spread or variability. The way to memorize how to compare between distributions is look at these letters right here. What does that spell out? Socks. I mean, misspelled, but socks, right? Okay. So comparing distribution, socks. Okay. Whenever you compare distributions, you want to talk about these 4 things. Okay. And then you want to mention the context and really use comparative language. Less. Okay. So whenever you do this, you want to make sure that you compare all those things, put it in context, and then compare which one had more, greater than, less than, etc. Okay. Once you finish that, look at the previous page. I got you. Look at the previous page. Okay, and we're gonna go over those answers really quick. Majority of y'all did pretty well on the gallery walk. I do want to take a couple of minutes and just kind of look over everybody's. So does everybody have their packet filled out with your answers from yesterday? Yes, no, maybe. I'm getting some blank stares. Okay. What I'm gonna do is I'm gonna give you about 5 minutes. I want you to walk around the room. Okay, all of y'all's are posted around the room. Some of y'all went into depth and some of y'all didn't. Okay, so I want you to look at what everybody did. Okay. So go ahead. You're gonna get up. You're gonna walk around. It's all the way around the room. So don't everybody go to the board. Okay, spread out. okay, and give you about 5 minutes to just look at what everybody else has down, okay, and compare it with what you have. Everybody got it? Okay, so go ahead and get up and go walk for about 5 minutes. So everybody's good on 1 through 4. Okay, I feel like 5 and 6 is where we're probably going to have some problems. I saw a lot of us didn't really answer 6. Maybe it was because we ran out of time or not, whatever it was. Okay, so on number 5, it says an outlier is a data that is way too small or way too big. Using the rules below, are there any outliers? So we're going to say less than Q1, which is 61.5, minus 1.5 times the IQR, which we found was 5. That's going to give me 54. So are there any low outliers? No. Okay. All right. What about big? Anything greater than 66.5 times 1.5 times 5?
Yep.
And that's going to be 74. And 77 is an outlier. Okay. The box plot needs to show outliers. Okay. Which we're going to talk about that in just a second. Okay. How do we pronounce his name?
Asmi.
That's what I thought. And then I was like, I don't think so. Ashmita? Okay. Is 63 inches tall. How does her height compare with other AP Stat students in her class? She has the median height. She has the median height. So she is taller than how much? Of her classmates. And she's shorter than how much? Shorters. Okay. Shorter than 50%. Okay, here's where a lot of you went wrong. A lot of you just wrote, and I know it's because like we live in a world where we just like answer the question, move on. A lot of you just wrote this. Okay, if we are comparing, which it says compare, you have to say something like she's greater than, she's less than, these things. Does that make sense? Okay, comparing, you're using greater than or less than. Don't just say she has a median height. Okay, median height means what? Okay, you're acting like the AP graders are dumb. You have to explain it to them. Yes. Okay. Everybody okay on this?
One question.
So what does that mean?
She's average. Not should be a bit below average. It's not like the mean. Should be a bit below average.
Should be a bit below average. Okay, so if we are skewed right? Because we got that outlier, right? So is the mean bigger than or is it less than the median? Convince me.
Because when it's skewed right, the outliers are on the higher end, and the mean is more affected by outliers than the median is.
Okay.
Which means that the mean would be bigger than the median because it's affected by those higher end outliers.
Mean is bigger than the median.
Do we hear more data on the left side, and therefore there will be more pushing it to the left than there would be? The higher the size. And there's also limits how far the outlier can be to the right. No, it can always get bigger.
Okay. Look back at your quick notes from lesson 1.3. Look back at your quick notes from lesson 1.3, where it says skewed right and skewed left. Look back at your notes from 1.3. Skewed right and skewed left. You told me that it's skewed right. So what does it say? Mean is bigger than median.
Also, if you look at your whisker plot, that median line, right? Half the data is to the left of that median line, half the data is to the right. The right-hand side is private ones.
Okay. So is she below or above average height? Below. Yeah? Does that make sense? Okay, that might be one that you just got to memorize. Like if you're like, I don't understand that, memorize it then. Yes.
It's skewed left, median is greater than.
So skewed left, mean is less than median. Here, I'm gonna write this down so you can see it visually. So skewed left, the mean is less than the median. Skewed right, it's the opposite. Mean is greater than the median. Okay. Again, if you are like, why? Memorize it, and then we can talk about it with a data set, like a tangible data set. Cool? Okay. Questions, comments, concerns? I know for most of you, the TI Nspire is a little new. It's like its own little beast, right? Okay, so definitely want to get that practice with it. But if you do have a TI Nspire and you're trying to go from decimal to fraction, this is how you do it. You type in the decimal, and then you hit menu 22, and then you hit enter. I'm going to make you a lovely little sheet of like how to use your calculator. Okay. But remember, you can't use that on the AP exam. So the more that you practice it, the better you're going to be. Now, if you're going from fraction to decimal, you're going to hit, it's control. So from fraction to decimal, you're going to hit control. And then there's like this little bar at the bottom. Is it enter? Is that the actual button? Somebody answer me on that one. Enter. It should look like little bars. It's on the right-hand side down at the bottom. Approximately. Yeah. Okay. So from fraction to decimal, you hit control and then you hit enter. And this is the little symbol that you're trying to get to. Does that make sense? Yes, no, maybe. Okay. All right. Going over these answers really quick. Okay. Where are we at? 3. Okay. So on here, number 1, part A, what is that?
Quantitative.
Quantitative and continuous, right? Quantitative and continuous, because you can have a temperature of like 98.6, right? Okay. Part B, is it quantitative or categorical? Quantitative and discrete, okay? With population, you have to have a certain number of people, okay? The brand of each car in the student parking lot, is that quantitative or categorical?
Categorical.
Categorical. It's whether they have a Tesla versus a Bronco versus a whatever, okay? All right, number 2, hopefully you made that dot plot. I feel like I don't have to go over that with y'all. Okay. Hey, biggest mistake that people make is they don't label their dot plot. Did you label your dot plot?
Nope.
Did you put like something at the bottom that says test scores?
No.
Oh, failure. So like that's a point right there. Like already points off. Okay, so you got to be careful. Okay, the mean, what'd you get?
83.45.
83.45. The median, what'd you get?
82.
82. Good. All right. Which measure of center is most appropriate to describe the data and why? Why?
It's skewed right.
Okay. So you've got an outlier of like 97. Yeah. Okay. And it influences it, which means it influences the mean more than the median. So you're going to use the median. Okay. Because remember, mean moves depending on the outlier. Median is true. Yes.
Like when I ask these type of questions, like you have to calculate the outlier and prove that there's actually no way to consider this one. I think this would like what's possible.
That's a tricky question. Yes, you can say there's a possible outlier. But on this question, you want to be absolute, so you should calculate it. Yeah. But you could say, hey, 97 is a possible outlier because it's not asking you to actually do that calculations prior to. Yeah. If it did ask you for the calculations, you need to show all of that. Yeah. Yes, you could say possible. Here. I would take that. Okay. Number 3, what was the median?
81 degrees
Good.
Fahrenheit.
Good. And include those units. Okay, range.
18.
28. 28. Look at it. Range, remember you're taking your highest to your lowest. So that should have been 91 and 63. Okay, this is where I saw a lot of blank papers. It was describing the shape of the distribution. Okay, so if I were to draw a little thing on here, what does this look like? Like turn your head to the side. Turn to the side. Okay, it looks kind of like Goliath, right?
Skewed left.
Skewed left. Okay, I loved the fact that all y'all were like this. Okay, so this is skewed left. Look at the big hump right here, little over here. You got a tail over here. We're going to say slightly because we're not really sure. Because look at this column. This kind of throws it off a little bit, right? Slightly skewed left. I can see y'all are already agitated with the adverbs. Yes, babe. No, because you don't have another column here. If you had like another row here and you had some numbers, then you could probably say roughly symmetric, but no. Okay, yes. The median was 81. We okay? Okay. I'm going to be perfectly honest with you. You need to practice this. This is probably the hardest part. Yeah. And it just comes with practice. Yeah. Okay. Number 4. Describe the shape of the distributions. Let me scroll down. Okay, what's the first one? Yes. Skewed left. Okay. What about B? This one gave y'all a lot of trouble. A lot of y'all started saying bimodal. It's got to be clear. Like it's got to be like thick columns. Okay. So this is going to be roughly symmetric. Adverbs. My least favorite thing. Okay. Now on 4C, here it is. This one, you could say roughly symmetric, or you could say bimodal. There's arguments for both. You see how big these columns are right here? Okay, so we could say bimodal, but we could also say roughly symmetric with that janky curve, but yes. Okay. I would say bimodal probably because of these two columns. Yeah. Good. It's almost like for bimodal, you have to have like a ton of data in order to really call it that. Yep. It's going to give you something similar to the stem and dot stem plot.
Under like example, we just like, can we do it to like make sure, or like, would it be like give us like a different thing?
So if they ask you the shape, either A, they're going to give you like a data table, and then you have to create like a stem plot or a dot plot, and then you could tell the shape from that. Yes, you could draw it out. Now, I would get super comfortable with your calculator because if you're drawing them every single time, it's going to take a while. So you want to make sure that you're quick with it. Okay. Did y'all do number 5 yet? Okay. So number 5, the average, or I'm sorry, what score does he need to get on the 4th game to raise his average score by 5 points? That's going to be 166. So after the bowling game, he had 146. So his average score was 146 after 3 games. So what does he need to get on his 4th game to raise his average by 5 points? So you would look at this. I'm sorry. this would be 4 down here. You would add 5 points. That would be 151. And so what would be the average? Your average score was 146, right? Okay, so what was his 3 scores here? 146 times 3, which is what? Okay, so your total was 438 here, right? So how do we get this?
You add like what I did 48 plus X over 40. And then from there you figure out the
So you would multiply by 4 and then subtract that 438. Does that make sense? Is that good? Okay. Everybody okay on that? All right. So let's go ahead and pause. Okay. For your quiz, because I want to give you enough time to actually complete it. Okay. Telling you right now, the first question is going to ask you identify the individuals and identify the variables of the data set. Can we do that? Is the answer A? No. No. Okay. On the next one, it's going to ask you to create a table. Yep. Okay. I did give you boxes on there. If you want to like redraw the boxes, that's okay too. It's going to ask you for a segmented bar graph and to compare the distributions. When we compare, what words do we use?
adverbs.
Not adverbs.
Not adverbs.
Greater than or less than. So when we compare, we're going to use one of the greater than, less than. You're going to use the alligator symbols, right? We'll put it in words because we're using stats, right? Okay. Again, the next question is compare these 2 histograms. Okay. The next one's going to ask you about a stem and leaf plot. Everybody okay on reading those? Okay. And it's going to ask you why the mean would be less than the median looking at the stem plot. Okay, so it has something to do with the shape of the graph, has something to do with outliers. Yes. Okay. The next one's going to ask you about measure of center, measure of variability, if it would increase, decrease, or remain the same if you added in a number. So that's kind of like what we did, it was yesterday on like 1.4, where we added in that 7. Do you remember when we added in that 7 degrees Fahrenheit? How did it impact the data? Okay. The next one's going to ask you about misleading graphs. Okay. And the last one's going to ask you for a mosaic plot. Okay. Everybody okay? Yep.
Like the mosaic plot is like the one we did like earlier this week, but like he's repeating it. Or
Yes, if you're projecting for like 100 versus the 500.
Yep.
Okay. This one is going to ask you about elderly versus not elderly. Remember that you have to convert to relative frequency before you start doing anything. Percentages? Yes. Okay. Questions? Okay. I'm going to let you use your calculator if you have it. If you need a calculator, I've got a couple extra ones. These aren't obviously the fancy ones. Okay. If you need one, you can come grab one. Make sure it works. Okay, because some of those just don't. Okay. All right. Make sure you write your name on it. Make sure you answer in complete sentences. Show all of your work. Okay, so I can give you points. And then go ahead and clear off your desk. You need something to write with. Kind of briefly go over what your quiz or your test is gonna look like. That box right up there. So just as a side note, your exam format, you got multiple choice section, you got a free response section. Look at the time that you have on that. That's an hour and 30. Okay. Got an hour and 30 for both sections. Okay. How many questions did you have on your quiz?
5, 6.
That's 6. Now, I will say this. On those 6 questions on your FRQ, you have multiple parts. It's not just 6 questions. Okay. So this weekend, I need you to practice with your recommended assignments on your textbook. Those you need to get done. Remember, your test is Tuesday. So Monday, we're going to do a calculator review, and then we're going to review for the test. And then Tuesday, you're taking your test. So if today made you panic, you got some work to do this weekend. Okay? Everybody okay? Okay. All right. Have a good weekend.